Okay, today we're talking about some special right triangles. And the two I believe they're going to talk about are right triangles that have 45-degree angles. Let's do that. And the other one we're going to talk about is right triangles that have a 30-degree angle and a 60-degree angle. And what you need to write down for this is this, which mine isn't supposed to be what it should be. Both of these sides should be equal. So there's no way to do a right triangle that has two other 45-degree angles other than to be an isosceles triangle. That's the only way, because it just is. Write this down. Put a 1 here and a 1 here. Okay. If I use the Pythagorean theorem, which says what? A squared plus b squared equals c squared. And I do the math with this. 1 squared plus 1 squared equals c squared. 1 squared is 1, and 1 plus 1 is 2. So if 2 equals c squared, anybody have any idea what c equals? There's no exact answer to it. C just equals the square root of 2. What number times itself gives you 2. So write this here. This is what you need to focus on in your notes when you see this. Okay? Because of this relationship here, anytime you see they give you a triangle that has a right angle and two 45-degree angles, you want to think of this triangle. Okay, because of this. Here, let me give you another one. If I have a right 45-degree triangle, and I know these are 45 degrees, and I say that this is 6, right off of the bat, you can tell me what the other two sides of that triangle are. Why? Because they're similar triangles, and you already have their ratios here. Okay, in other words, this. To go from 1 to 6, what do I multiply by? 6. So this other one's going to be 1 times 6, which is 6. And 6 times the square root of 2 is going to be, no, 6 times the square root of 2. You can't multiply non-square root numbers with square root numbers. You just put the number in front. This is 6 times the square root of 2. You can't multiply those together. There is one, we just don't know what it is. You can get awful close. With that thought in mind, see if you can make this big jump here. If you have again, all these have to be right angles with 45-degree triangles. If I know that this is 10 times the square root of 2, you can tell me what the other two sides are. Jeremy did? Jeremy, what is it? 10. Why, Jeremy? Because Jeremy sees look at 1, 1, 1, 6, 6, 6. Okay? No matter what number comes in front of the square root of 2, if it's this special triangle, that's what the other sides are going to be. Okay? It's going to be the same number that way there. And they're just trying to get you to recognize that. Now the next one might not be quite as, and we'll look at a couple of examples here in a second. The other one is a 30-60 triangle. In other words, it looks like this. You've got the right triangle, you've got one angle that is 30 degrees, and the other angle is 60 degrees. And here are the proportions or the ratios that you use for this. If this side is 1, okay, if these angles are true, if this side is 1, this is twice that. Okay, and the hypotenuse, if you do the math with the Pythagorean theorem, is the square root of 3. Okay, this is, you don't even have to understand why it is. You just have to know that this is your reference triangle. When you see a 30, 60, 90 triangle, you refer back to this and look at it. Here's the case in point. Here's my new triangle. All right, I'm going to do this. You know, I know that this is 30 degrees, this is 60 degrees, this is a right triangle. If the short side on this 30, 60, 90 triangle, let's say this is 8, okay, I know that the other leg has to be twice that because the ratios stay the same. Because 2 is 2 times 1. Same thing's going to be true here. I take 8 and double it for the longer of the legs. Okay, short leg is half of the long leg. And then the hypotenuse is, what would that be?
1/2, 1/8. Square root.
Exactly. It's whatever this number is in front of the square root of 3 because that's what's in front of the square root of 3 right now. It is 8 times the square root of 3. It's just a reference thing. Okay, let me give you another one. If I have a 30, let's put it on its side. Let's do it like this. Here's my, oh no, that's not dead spot. Here's my 30, 60, 90 triangle. Okay, if I knew that this is 10 times the square root of 3, you can tell me the other two sides because the relationship between the sides are the number that's in front of the square root of 3 is the short side, and the other leg is double the 10, which would be 20. Okay, it's all just relationships. You just kind of figure out the pattern there and go, okay, well that's what it has to be.
So, like, do you put 20 for the other side, or is the 10s on
Give
the,
me a 20 where?
the,
The short side?
yeah, could it be there, because?
No. The short, you have to go by short and long sides. You can't go by left side, right side. Okay, the short side, whatever number the short side is right in front of the square root of 3. And the long leg, you should call these legs. Short leg is that, long leg is twice the short leg. And you're going to say, hey, let's see about if I can pull one up here. What do we got here? What is it? What class is this? Math stuff. On the math stuff is Jackson, you are course 3. We are on course 3 what?
66.
66. I was hoping somebody would say 66. 5, 4, 2, 3, 1, 2, 1. L blast off.
Oh.
Wait, did I just put it in there?
No, it had the circle.
Oh, not the circle of death.
Nathaniel, it's because of Nathaniel.
That's not good.
Nathaniel, what did you do?
I sharpened my pencils.
He
slapped me too.
He sharpened the system.
Because it's a lie.
There's,
Selfish. I screaming lies. He's so weird.
nope. Oh, let's take a look at this one. Because this one might not be entirely obvious, but there are some applications here. Look at this one. It says a Major League Baseball diamond is a square with sides that are 90 feet long. If a base runner tries to steal second base, the catcher throws the ball from home plate to second base. How far does the catcher throw the ball? In other words, they're asking you this. How far is it from home to second? Okay, well here's the deal. Let's draw it out. You know this is 90 feet. Okay, you know that these are all 90-degree angles. Well, if you draw a line from this diagonal to this diagonal, what special triangle is this? I just cut 90 degrees in half, so it is these are 45-degree angles. And what do you know about 45-degree angles? okay, that the two legs are the same. And what is the relationship between the legs to this side? We're only talking about this triangle right here. Look at the hypotenuse, look at your notes, what is it? Right, so this side here is 90 times the square root of 2. Which the square root of 2 is what?
1.01.
What is it?
Or 4.
1.41.
Write this down so you know what the square root of 2 is. 2 square root is 1.414. 1.414. Write that somewhere where you know where it's at all the time. Same thing with the square root of 3. Where did it go?
141. 141.
Square root of 3 is 1.732.
The square root of 3 is what now?
1.732. You just need to know it, because if they had asked you how far is that to the nearest foot or whatever, you would actually have to take 90 feet and multiply it by 1.414. That's fine, whatever it is. You know it's gonna be almost 120 feet, isn't it? Because it's almost 1.5, that'd be 135 feet. Let's look at another problem. Letter A says sketch a 45, 45, 90 triangle and indicate the angle measures and side lengths if one leg measures 1 inch. What's one side, the other side, one side, the other leg is gonna be, and the hypotenuse is gonna be square root of 2. Letter B says sketch a 30, 60, 90 triangle. Sage, you need to go on the hall, would that make life better? Was Brandon influencing you in a negative way? I'm just asking.
Yes.
See, here's-
He always pushes this chair towards me, and when I try to give back to him.
Well, Brandon, where should that chair be? So why is it not next to you? Huh? Well, why don't you put it next to you where it should go? And then Sage won't get in trouble and you won't get in trouble. And everybody's happy. Right, Nikki, you're happy. Sage, the reason you always get in trouble is because, see, Brandon's a little on the sneaky side. He doesn't make much noise when he does that, but you're the one over there giggling and making noise, so. There's a saying that says the squeaky clicking pen gets the grease. What's that mean?
That means it doesn't pay it.
Let's look at problem letter B. A 30, 60, 90 triangle. Sketch it and indicate the measures on the sides. They're just giving you the reference one. If the shortest side was 1 inch, if the shortest side was 1 inch, you should be able to tell the other sides, because that is your reference triangle. If the short side on a 30, 60, 90 is 1 inch, what is this side? 2. And this side is 3. Oh, look what they asked you. What are the approximations for the square root of 2 and the square root of 3?
1.414, 1.7.
Yeah,
Yeah, remember this is.
Alright, that's enough of that.